Hello students. So today we are going to discuss about application of congruence theorem. In our last video we already discussed about what congruence theorem and conditions of congruency. Today we are going to solve some questions, 2 or 3 questions, so that you can easily understand how we apply the congruence theorem if any problem of mathematics you face during your solving the problem of exercises. So let's start. As you are observing, there is a triangle. Name the triangle. It's a B and this point is O. So name the triangle. It's a B O. And question says that this is your triangle. In this triangle, this side extended up to this one and this side extended up to this one, such that this side is equals to this side, though it's not like it look like equal, but if question says that it is equal, then you have to consider that it's equal, and this side equals to this side. Question says that prove that CD parallel, this is your CD, this is your point CD. Question says that prove that AB is parallel to CD. How we prove this one? We have to prove that these two triangles are congruent, and then we prove that these two triangles are congruent, these two angles are alternate interior angles are equal, and these two also. Then we can easily prove that this is parallel to this one. Let's start how we prove. First, we prove the congruency in triangle AOB and triangle COD. These two triangles, as we know that in triangle this side equals to this side. So AB, sorry, not it's AB, it's a BO equals to OD. It's given, and also AO equals to OC, it's also given, and even you can, this angle is equals to this angle. Why? Angle AOB is equals to angle COD. Why? It's a vertically opposite angle, and these two parts are given. Therefore, we can say that triangle AOB congruent to triangle COD. Which property we are using? By side angle side property. Clear? This is your congruency. Then, if we can easily prove this one, then after we can write by using CPCT. By using CPCT, that angle OAB. So here angle OAB equals to angle OCD, and also ABO, angle ABO equals to angle ODC. This is by CPCT. This is by CPCT. Therefore, we can say if we see these two, if these two are parallel, this is your alternate interior angles. So if alternate interior angles are equal, then lines are parallel. Angle OCD, alternate interior angle. angles. AB, it's proved that AB parallels to CD, it's proved. This is your such type of you apply the congruence theorem in problems you face in your exercises. Yes, in the above figure, in front of the figure, it says that this is your angle ABC and line BX bisect the angle ABC. It is written over here, this point. Then it also says that line POQ is perpendicular on bisector BX. Question says that prove PO, this one is equal to this one. This not look like equal to, but you have to prove that by using your congruence theorem. So let's start. In this case, we have two triangles. In triangle POB and triangle BOQ, this one BOQ, what a these two angles are equal and this side is common, and even these two angles are also equal because this is a bisector. So we can write down angle BOP equals to angle BOQ equals to 90 degree. Angle PBO equals to angle QBO, it is given, and also line BO is common. Therefore we can say triangle POB, this one, congruent to triangle BOQ. Which property? We are using angle side angle. Then by CPCT we can say that therefore PO, this part and this part are equal. PO equals to OQ by CPCT. And hence your solution is proved. It's clear? Now move to the next question. As you are observing that in following figure it is given that it's a POQ is an angle and BX and AXA are perpendicular on these two arms. These perpendicular meet at point X. We join the line OX. Question says that you have to prove OX bisect angle POQ. This one POQ. Let's start. Again, in these two triangles we have this side common, this side equal, and this is your right angle. In triangle OXB and triangle OAX, at very first OX is common. It's not OLX, it's a OX is common. Clear? And also it says that it is given that BX equals to AX. It is given angle XBO equals to angle XAO equals to 90 degree. So right angle, opposite hypotenuse, and one of the side equal. So we can say OX be congruent to triangle OXAX by RHS property. Right angle, hypotenuse and any one side equal. Therefore, we can say that this angle must be equals to this angle by CPCT. Angle BOX equals to angle XOA by CPCT. Congruent part of congruent triangle. Clear? Then these two equals, therefore we can say OX bisect angle POQ. It's proved. Move to this today's last question. Now look this figure. In this case, it says that angle A and angle D, these two are perpendicular and side AC and BD are equal. Question says that prove that triangles are congruent. Very simple question is there. So let's start. In triangle, I'm simply discuss. I'm not going to write down anything because only simple congruency proof is there. In triangle ABC, this triangle, and in triangle DBC, what we have? We know that this side is equals to this side. Angles are equal and hypotenuse opposite to the right angle are equal, common. So by RHS we can easily prove these two triangles are congruent. So likewise you can apply congruency theorem. There are many questions, some looks like critical, but if you work out step by step you can easily complete your task. So I am leaving on you rest of the questions, especially question 8 and question 9 of 18th B. 8 and 9 on you. All of you must try to solve this one. I am not going to answer this one because you know, all of you know how to prove congruency and other CPCT part. That's all for today. We have completed syllabus, and what we reduced we can let you in message. Thank you.